Hi everyone! In this video, we will show how to run a univariate normal model using the graphical user interface and the dataset provided in the GitHub repository. In this example, we have data on football player values, where we want to identify which variables are most important in predicting the player's value. So first, click on Browse and choose the dataset provided in the GitHub repository named One Value Football Players. Once it loads, you will see a preview of the data and all the variables included in the dataset. Then you can set how many MCMC iterations you want the model to run, as well as the burn-in size and the thinning parameter. Once you set this, go to the formula builder, where you can choose which variable is dependent and which variables are independent, depending on the model you want to estimate. Click on Build Formula and you will see the main equation, which you can edit according to the needs of the model. For example, in this case, we will take the logarithm of the variable value. You can also change the prior mean if you want, as well as the variance and covariance matrix. Note that when you modify the covariance matrix, it may turn red, indicating that something is misspecified, since it must be positive semi-definite. You can also set the shape and scale parameters, which affect the variance specification. Once the model is fully specified, click Go at the bottom to run the estimation. The app generates a posterior summary of the parameters using MCMC simulations. This output shows the estimated distribution of each coefficient rather than a single point estimate. This section describes how the MCMC algorithm was run. It tells us how many iterations were used, how many samples were kept, and how the chain was constructed. Here we have the posterior mean of each parameter, which we can interpret as the Bayesian estimate, along with measures of uncertainty, such as the standard deviation. Since the dependent variable is in logarithms, the coefficients can be interpreted as approximate percentage changes in the player's value. For example, Perfil-Jarm 0.0036 means that a 1 unit increase in performance increases the player's value by approximately 3.6%. H2-Sum 0.022 indicates a nonlinear concave effect, meaning that the player's value increases with age up to a certain point and then starts to decrease. These are the posterior quantiles, which allow us to construct credible intervals. For example, the 2.5% and 97.5% values define a 95% credible interval. This output summarizes the posterior distributions of the model parameters, including their central tendencies, uncertainty, and convergence diagnostics, allowing us to perform inference in a fully probabilistic framework. You can also download the posterior chains as a CSV file and the posterior graphs as PDF or .eps files. I hope this video was helpful. Thanks for watching.